Okay, that's the definition. We first find f of x plus h. We substitute x plus h for x in the original function. That's x plus h squared. And now we need to expand this. X plus h squared is x plus h times x plus h. X times x is x squared, plus x times h is xh, plus h times x is hx or xh, plus h times h, h squared. We can simplify this. Xh plus hx is 2xh or 2hx plus h squared. Now if you guys remember this identity, a plus b squared is a squared plus 2ab plus b squared. You can use it to expand this. This is a and this is b. Applying the identity, we get a squared, which is x squared, plus 2ab, which is xh, plus b squared, which is h squared. So please memorize this identity. It's a shortcut to expand this expression. Now that we have f of x plus h, we need to find f of x plus h minus f of x and then divide it by h. F of x plus h is x squared plus 2xh plus h squared. So x squared plus 2hx or xh plus h squared minus f of x, x squared divided by h. This is a minus, right? We have x squared minus x squared. These two terms cancel, and we're left with 2hx plus h squared on the top over h on the bottom. The derivative of f of x is defined as the limit as h goes to 0 of f of x plus h minus f of x over h, but this is 2hx plus h squared over h, so it's the limit of 2hx plus h squared over h. This is also the limit as h goes to 0. We can factor out the numerator of the fraction by h. We can pull out the h, so that's h. If you remove h from each term, we have 2x left plus 1h left and divided by h. We cancel out the h's. F prime of x is the limit as h goes to 0 of 2x plus h, and this is 2x plus h goes to 0, so when you see h you plug in 0 for h, and 2x plus 0 is 2x. The derivative of f of x equal x squared is 2x. Here's another example. F of x equal 3x squared minus 5x plus 7. We begin by finding f of x plus h, which means plugging x plus h for every x in the original function. So we have 3 x plus h squared minus 5 x plus h plus 7, and we expand. Let me remind you that a plus b squared is a squared plus 2ab plus b squared. This is a and this is b. So we have 3 bracket a squared, which is x squared, plus 2ab, 2xh plus b squared, h squared, minus 5 bracket x plus h plus 7. Let's expand this further. We have 3x squared plus 3 times 2, 6xh, plus 3 times h squared, 3h squared, minus 5x, minus 5h, plus 7. This is f of x plus h. I'm going to copy it here. It's 3x squared plus 6 xh plus 3h squared minus 5x minus 5h plus 7. Now the limit of f of x plus h minus f of x over h, which is the very definition of the derivative, is the limit when h approaches 0, f of x plus h, which is this monster, 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 7 minus f of x, this is f of x, 3x squared minus 5x plus 7, 3x squared minus 5x plus 7, and the whole thing over h. Now it's time for cancellation. 3x squared minus 3x squared, they cancel. Minus 5x minus 5x, that's minus 5x plus 5x, so these two cancel. And 7 minus 7, so we're left with 6xh plus 3h squared minus 5h on the top and h on the bottom. F prime of x equal the limit when h goes to 0, 6xh plus 3h squared minus 5h over h. We have h squared h is a common factor, so we move out h, and we're left with 6h plus 3h minus 5 over h. And we cancel out the h's. We have limit when h approaches 0 of 6x plus 3h minus 5. This is not h, this is x, right? Because 6xh, when you move out the h, you're left with 6x. Not 6h, but 6x. We have 6x minus 5 plus 3 times 0, right? 3 times 0 equals 0. So the final answer is 6x minus 5. So what's the derivative of this function, 3x squared minus 5x plus 7? Its derivative is 6x minus 5. F of x is x cubed minus 5x squared plus 4x plus 7. Plus 7. As usual, we begin with f of x plus h, which is x plus h cubed minus 5x plus h squared plus 4x plus h plus 7. Now we do know that a plus b squared is a squared plus 2ab plus b squared. This will be useful for x plus h squared. For x plus h cubed, a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Think of x as a and h as b. According to this, we have x cubed plus 3a squared x squared h plus 3 x h squared plus h cubed, okay, minus 5 bracket x plus h squared is a squared, so x squared plus 2ab 2xh plus h squared b squared plus 4x plus h plus 7. This is a minus, this is a plus, and this is a plus. Okay, this is a mess, I understand. We need to expand it and see if we can cancel some terms. So we have x cubed plus 3x squared h plus 3xh squared plus h cubed, 5x squared minus 5 times 2, that's minus 10xh, minus 5 times h squared, that's minus 5h squared, plus 4 times x, it's 4x, plus 4 times h, it's 4h, plus 7. And actually, I don't need those brackets. This is f of x plus h. And now we want to do f of x plus h minus f of x over h. So we take this, we minus f of x. F of x is x cubed minus 5x squared plus 4x plus 7. So minus this, x cubed minus 5x squared plus 4x plus 7, and the whole thing divided by h. Okay, x cubed cancel x cubed because of this minus, right? X cubed minus x cubed is 0. The minus 5x squared cancel, the 4x cancel, and the 7 cancel. And so we're left with this, and this, and this, and this, and this, and this. Okay, let me rewrite this. So f prime of x equal 3x squared h plus 3x h squared plus h cubed minus 10xh minus 5h squared plus 4h. The limit when h approaches 0, as usual, we move h out. 3x squared plus 3xh plus h squared, right, because we remove one h, minus 10x minus 5h plus 4 over h. And we cancel the h's, and we let h equal 0 in the final expression to get 3x squared plus 3x. H is 0 plus 0 squared minus 10x minus 5 times 0 plus 4. And so the derivative of f of x is 3x squared, this is 0, this is 0, minus 10x, this is 0, plus 4. So this function, x cubed minus 5x squared plus 4x plus 7, has a derivative which turns out to be 3x squared minus 10x plus 4, and that's f prime of x.